In this episode, let's talk about the next topic on mensuration, which is called as cube. And the cube is almost exactly same as the previous thing that we covered on cuboid, with the only difference that in cuboid, all the surfaces were rectangular in shape or rectangle, and in cube, all the surfaces are squares. That's the only difference. And rest of the things all remain the same in terms of all the angles are still right angles and 90 degrees. So just imagine that it's all square, all sides are square, and this is the example of a cube, the Rubik cube that you would have seen while you're playing with this. That's a typical example of the cube, sorry, where all the side surfaces are square in shape, and this is kind of the empty version of that. And like a cuboid, it has 6 sides and everything remains the same except for the shape. And if you see this example, we already seen in cuboid, where you can assume that if a cube is kind of opened up, this is how it looks like, and there's a very good animation. If you go out and check out this website, there's a very good animation which shows this particular visual where you can open it up and how it forms, in case you're interested. Otherwise, nothing specific about this topic. And like I said, in mensuration, you don't have to memorize all the formulas. The only thing you need to do is you need to remember some, and others you can derive. So if you can remember the cuboid, and the cube will be pretty much, you don't have to memorize the cube formulas, because since it's a square, all the dimensions are going to be the same. The length is equal to the breadth is equal to the height. All the dimensions, this part, and this part, all are going to be same. You just need to substitute in the cuboid formula if you remember that. In case you don't remember, let's check it out. Okay. I've copied different visuals, whichever suits you, you can pick up for imagination. And for different terms and terminologies, I don't think you need to remember all. And there's the term when you open up the box like this, that's called as a net of a cube or net of any 3D object. Net, that's a terminology. Again, you don't have to remember, not very important. And this is what you get. Like I told you, once you open up the cube, there's like 6 sides, 1, 2, 3, 4, 5, and 6. And if you kind of open this up and close it up, you get kind of this kind of a shape. So plenty of visuals for you to imagine what is a cube, and you can draw parallels to the cuboid, which was rectangular in shape. Okay, now for a cube, since for a cuboid we had 3 dimensions: height, length, and breadth. Although this is a cube, for cube we know that all the faces are going to be square, or all the sides and surfaces are going to be square in shape, and hence these dimensions are going to be the same. So this is very important, and that's the only difference. The length is equal to the breadth is equal to the height for a cube, and we just need to substitute those values in the cuboid formula. But again, let's do it ground up. So what is the volume of a cube? Volume of a cube is nothing but how much space a cuboid has, or how much water it can store. You can think about that. Like, what is the space inside this? Okay. And like any space, what you can think about a volume is, let's say you have a rectangular or you have a square shaped paper, and you keep on stacking up paper on this. You keep on stacking up or piling up paper on this, or square books on this one. So this is how it will look like. Okay. So if you want to calculate the volume, what you can calculate is, let's say if you just have one square sheet at the bottom, and this is the length and this is the length. Okay. So the area of this is length square. And if you keep on piling up square sheets on the top of that, this is how it will look like. So there is a height dimension that is added. But again, that height is going to be again length L, because all the dimensions are going to be same for the cube. If you see here, we got it from here. And hence, we don't have to worry about the length, breadth, and the height. We'll call everything as L or B or H. It doesn't matter. So in that case, what is the volume of a cube? The volume of a cube is nothing but the area of the square into the height. The area of the square is going to be length into breadth into height. But since we know all the sides are equal, we just take length and length and length. And hence, the volume of the cube is L cube, cubic unit. This is very important. Whenever you have volume, always put the cubic units. So the volume of a cube is L cube, cubic units. Okay. Similarly, let's go and understand the surface area of a cube. If you remember, we already discussed that there are typically 2 types of surface areas for this kind of objects. One is the total surface area over here, and another is the lateral surface area. And the difference, like I've repeated in the previous episode, when you say total surface area or TSA, it means if this object has 6 sides, okay, like I told you in the previous, like if you see here also 1, 2, 3, 4, 5, and 6, you take the areas of all the 6 sides and add it up. That's called as a total surface area. And when you say lateral surface area, it's also denoted by LSA, lateral surface area. In this case, you exclude the top and the bottom. Only the lateral parts you include. Lateral means sidewise. That's the meaning of lateral, all the sidewise. So exclude the top here and the bottom here and count all the sides. That means it is going to have 4 sides. That's the only difference, okay? And since we know that all the lengths are equal, in this case the length is denoted by the value S, but you can also call it as L, doesn't matter, whatever variable you call. So each square's surface area is going to be just a square of that length, or S square or L square, whatever is the length multiplied by itself to the square, and that's the surface area of each square, because we know the area of the square is the product of the two sides, right? We know that if this side is L, this side is L, this is going to be L square. That's what we know. And likewise, each square, all the 6 squares are going to have the same area of L square or S square. Now, if you want to find out the total surface area, which is the area of all the sides, you just need to add all the sides, and this is how you will get it, right? Even if you do it individually, area of the top and the bottom, area of the left and the right, area of the front and the back, all these things, this is 2 sides, this is 2 sides, and this is 2 sides. Total we get 6 sides, right? Or if you add all of this. And since all the areas are going to be the same, like we discussed here, S square or L square, area of the top is going to be L square. That's what we get. Area of the bottom is going to be L square again. And this likewise the same. So total we get L square repeated 6 times for each of the side, once for each side. And hence, the total surface area of the cube is 6 L square units. We have to do square units here, not cubic, because we are talking about area. So that's how you remember. So like this, you can remember all the formula. You don't have to really memorize that. Just remember the clues. Okay, for cube, this is how I need to calculate the total surface area. And then that way you are not using your memory to save and store all the formulas that are very easy. Some of the formulas can be already computed on the fly. Lateral surface area, what you do is you just exclude the top. You don't have to count this area of the top and area of the bottom. Exclude these 2 sides and just keep this and this. So you get total only 4 sides. And since again it's going to be the same area of the left and the right side is L square plus L square, and front and back is L square and L square. Top and bottom we already dropped. So that gives us 4, because if we count this 1, 2, 3, 4 sides, 4 L square units. That's your lateral surface area. So that's what pretty much are the 2 important things, or 3 important things if you count volume of a cube, total surface area of a cube, and lateral surface area of the cube. So we have covered cube and cuboid. That should pretty much do it, and you will see a lot of interesting exam problems. So as long as you remember this formulas, it will be very easy for you, and hopefully it was not that complicated so far. So let's keep going, and I'll see you in the next episode.